Is weather forecasting just a complex mathematical equation? Can it be as simple as looking at simple parameters and knowing what happens next? Weather forecasting is a science and an art. You could have tons of data, but without experience or historical understanding of weather patterns and behaviors, all your data might be useless. But you and I don't have to go down this road and complicate our understanding of things. I can give you a quick overview of forecasting so that we're on the same page, and then discuss a few crucial things before concluding our class about the weather. As late as the mid 1950s, weather forecasting was based on historical records that meteorologists compared with current conditions for similarities. Now, forecasting is based on the product of 6 to 8 mathematical equations for a given point. Air pressure, wind speed, humidity, air density, and the result of surface and upper air measurements are fed into a supercomputer to run a suitable program. The program analyzes data from many grid points at the surface and up to 18 layers into the atmosphere. This predicts the future 10 minutes. This data is then refed to predict the next 10 minutes and repeated until we reach a desirable point into the future. Global climate models work with a grid of about 300 square miles per block, meaning your weather app gives the same reading for anyone within a 300 square mile radius. This is useful, but definitely not accurate. Smaller grids will be more accurate, but demand higher data storage and computation. Therefore, global models are less accurate than regional models, but global models help determine large-scale climate changes over time. In contrast, regional models are dependable only for a short period. Do you see the conflict here? The output from these global and regional models still needs to be analyzed by an experienced human interpreter for a more accurate prediction. Climate models are a bit different. They depend on a detailed description of the grid points. Each grid point is modeled by a land specialist, oceanographers, atmospheric scientists, and many other experts. Land specialists indicate topographic features like mountains, rivers, forests, water runoff on the surface, and the amount of water in the soil, among other things. Oceanographers describe salt content, freshwater runoff, sea ice, ocean temperature, and density in numeric models. Atmospheric scientists highlight the distribution of gases in the air, solar radiation affecting air temperature, pollutants, etc. It's still not dependable as minor atmospheric disturbances are greatly magnified over time. You can read about these effects in the chaos theory or just Google the butterfly effect. These models use data points too far apart to predict the movement of small-scale weather systems like thunderstorms accurately. Don't get me wrong, forecasting has come a long way in the last 100 years than 2000 years before. But the skill of understanding a small-scale weather system can take you a long way towards understanding the unpredictable nature of weather itself. Before all these changes and advances in forecasting, people could still accurately predict the weather. Homespun forecasting is a thing. Dozens of weather lores have stood the test of time, but it requires trust and good memory. Let me give you a few examples here. When you see birds going to roost early, what can you predict? There is rain or snow approaching. If you see a halo around the moon at night, expect rain. Some flowers, such as dandelions, fold their petals before a storm. Woolly bear caterpillars can predict the severity of the coming winter by the width of their black and brown bands. The wider the brown segment, the milder the winter. These weather laws are fascinating, and one would love to collect such statements to look out for in their weather prediction toolkit. So let's do something. If you know a weather lore or know someone who might tell you a thing or two, drop it in the discussion section. Let's put all of them together, test them, weed out the vague ones, strengthen the good ones with proof, and maybe compile a free book of useful weather lores for us to use and share. I'm sure it'll be loads of fun.